So what we'll do here is we're going to be looking at a few questions. What I want to say for the first one here is basically in a case like this, you're looking at prime bases. So what I'm going to do is I'm going to look at anything that's not a prime and try to turn it into a prime. So what that gives us is like that's 1 over 5 to the m, and then that's 1 over 2 squared to the 18. This, that's going to be 1 over 2, and then that should be 2 times 5 all to the 35, like this. So now everything's in primes, but I just have to simplify it. So that's 1 over 5 to the m, and that's 1 over 2 to the 36, like this. And that's going to be 1 over 2, and that's 2 to the 35, and that's 5 to the 35, like that. So basically at this point, we're looking for what the m is, right? And you can see that the m's attached to the 5, right? So the power in the 5, the m, has to be the same as this. So we can see right there that m equals 35. And you can of course see that that's 2 to the 1 and 2 to the 35, so it's 2 to the 36. But point being that m is 35. Now, if we were to look at a different case, so every integer k from 1 to 10 inclusive, that's the next question down, right? The kth term of a certain sequence is given by minus 1 to the k plus 1. Okay, so what we're looking at is that's going to switch back and forth regardless of whether it's positive or negative. I mean, what we're looking at is basically the k. So for k equals 1, that's going to give us a minus 1 squared, and then that's 1/2 to the 1. So for the k equals 1, that's just going to be 1 times 1/2, so that's 1/2. K equals 2, that's going to make the minus to the third power here, and that's going to be 1/2 squared. So that's going to be a minus 1/4, and you can see that this one's just going to switch back and forth over and over and over. So that's k equals 3, that's going to give us a positive here. That's minus 1, the fourth power goes positive, and that's 1/2 to the third power, so that's plus 1/8. And you can see that the pattern is just going to be k is 4 there, so that's going to be a negative, but it's going to be 1/2 to the fourth power, so that's going to be minus 1 over 16. So then it's talking about the sum, right? So we want the sum of the first 10. So essentially what I would do here is probably look at something like this. So I'll just make this k, and that's going to be the sum of the k's. So what I'm going to say is, okay, so we've got 1, 2, 3, 4. This is probably good enough for us to tell. So I start with 1/2 here at the first point, and then I go down by a quarter. So if that's 1/4, that's going to be my k is 1, k is 2, k is 3, k is 4. And then I'm going to go back up by an 1/8, and I'm going to go down by a 16th. And then what you're going to see is it's just bouncing up and going down a tiny bit more. It's going to end up here somewhere between 1/2 and 1/4, no matter what you do. So it's going to basically get closer and closer and closer to 3/8. That is halfway between 1/2 and 1/4, but not actually arrive at that. It's just going to balance out to that. So because it's always going down a little bit less than it's going up. So it should always be kind of moving slightly up, but it's going down a little bit as well. Now, if we move down to this, okay, so here, if we're saying the addition table shown above was the value of m plus n, all right, well, what we can do in this one is basically just say that's meant to be a 7. I don't know why it's not tracking here. What's the value of m plus n? Look, this is x plus 4 is 1. All right, so you can just start with that. X plus 4 equals 1. So x itself is minus 3. And then we get y plus 4 is minus 5. Y plus 4 equals minus 5. So y is equal to minus 9. Z plus 4 is m. Leave it there for a minute. X plus e is 7. And then the x is minus 3, so minus 3 plus e equals 7. So e itself is 10. Y plus e, y plus e, y plus 10 is equal to n. And then z plus e, z plus 10 is equal to 10. So z is equal to 0. Then, okay, so we know that, and we know that the y is minus 9 there as well, so we have that. I forgot about that one. So minus 9 plus 10 is equal to n, so n is equal to 1, okay. And then we've got z plus 4 is m, so 0 plus 4 is m, right? So 4 is m. You get that? M plus n is equal to 4 plus 1 is equal to 5. And you're good. So the answer should just be 5 there. Okay, so let's skip through this geometry there. So r plus s, r and s are integers, rs plus r is odd. Okay, so well, what we know is that we have odd plus even or even plus odd, if that's going to be odd, right? That's the only ways you're going to get odd, basically. Now, the thing is, it's not going to be both odd or both even, because that gives even, right? So one of these two is odd, one of the two is even. So point being, in this case, one of them has to be odd. But if we said, for example, that s is odd and r is even, then what we would get is we would get rs is even plus r is even, which then gives us even. So that's not going to work. It has to be the other way around. We're going to have r is odd, s is even, because then what you're going to see is you're going to see rs plus r then gives us odd plus even, which gives odd back. So what that's telling us, which of the following must be even, the only way it works is when s is even, right? So that's it, s is even. Now, okay, a company has two types of machines, type R and type S, operating at a constant rate. R does a certain job in 36 hours, so rate for R is 1 job per 36 hours, and then the rate for S is 1 job per 18 hours. And then that's going to be, if you put them together, common denominator, R total is R plus S is 1 job in, or sorry, 3 jobs in 36 hours, which is 1 job in 12 hours, is where I was going. Okay, so the company uses the same number of each type of machine to do the job in 2 hours. Okay, so what you've got basically is you're trying to do the same job, so it's 1 job is equal to n machines times 1 job per 12 hours times 2 hours, right? So here, that's going to be 1 over 6 times n is equal to 1. So your n, of course, is just 6. And the n there is going to be your number of machines. And then we'll do one final one here. So this question, actually we'll do number 10 as well, why not? Okay, x is not equal to 0, which of the following is equal to this? So this is, I mean, if you know the definition, as far as we're concerned, for GMAT purposes, the square root of x squared is the distance on the number line from x to 0, right? So it is essentially a definition of absolute value. So what you can look at there, well, that looks like absolute value x over x, and lo and behold, that's your answer, right? So there's an answer there. You can plug in the other ones to test them, because it's not going to work out. If you put in -1 here, that goes positive, that goes negative, it doesn't work. 0 clearly won't work because you're dividing by 0. 1 doesn't work because, I mean, it might work, but it's not always correct. That's the problem. So yeah, maybe it's 1, but you can't assume that it's 1. And then x, the thing is that, you know, at best, if x is positive, that's going to give you 1. If x, and then, you know, if you had a negative x for whatever reason, that would give you a negative. So it doesn't really matter. But point being, that's a definition that the absolute value of x is equivalent to x squared, the square root of x squared. Number 10. So what you want to do in a case like this is just factor out common terms, right? So 2 to the x, and then you can pull out a 1. That's 1, and that's base 2, right? So 2 to the minus 2, so that's 1 minus 1/4. That's 2 to the x, and that's 2 to the x, and that's 3 over 4, which is the same as to say 2 to the x times 1 over 4 times 3. This is the tricky bit, is to split out that 3 over 4 fraction. I'm leaving this to the side for the moment, because that's simplified. So that's going to be 2 to the x, and that's going to be 1 over 2 squared. 2 to the times 3. So 2 to the x times 2 to the minus 2 times 3 is equal to, this is where I'm bringing this part in, 3 times 2 to the 13, like that. And then that's going to give us here 2 to the x minus 2 times 3 is equal to 3 times 2 to the 13. X minus 2 and 13 are in the same position against the 2. So x minus 2 equals 13, and you can assume then that x is equal to 15. Okay? And that's it. Done. All right. Thanks everyone for watching, and I will see you in the next stream.